Hey guys, today we are continuing on with some more identities for trig functions, and this is going to be the half angle properties. So today we're going to use the half angle properties to simplify expressions and solve equations. So let's look at our formula chart. So these are the half angle or half argument identities. So if you notice you have a half of an angle, you have to use one of these formulas. So let's start by trying to take an expression and simplifying it. So the first thing is you notice that this whole thing is under a square root, and the only properties we really have that have square roots in them are going to be the half angle. So I automatically can go to my formula chart, pick one of the half angle properties, and I notice that this one has a minus sign in it. So that lets me know that this is going to be the sine of 1/2 of something. And now I need to decide what that 1/2 is going to be. And so if you look in your formula, the argument of cosine, or that x, is going to be your 1/2 of whatever. So we're going to take 1/2 of a. So again, this is like your x term in that formula. This guy right here, we could go ahead and simplify down. So that's sine 1/2 of 4 is going to get me 2. So this would just be the sine of 2a, which we do have a formula for as well, but that is pretty simplified to me. Okay, so again, if you're given a square root, you're probably looking at a half angle. So let's look at how would I solve equations or find sine of 1/2 x, etc. when I'm given a proportion like this, or sorry, not proportion, a ratio. So we have the cosecant of x equals 13/5, and you're given this domain restriction where pi over 2 is less than x is less than pi. So they ask me to go ahead and find the sine of 1/2 x, the cosine of 1/2 x, and the tangent of 1/2 x. So the first thing I'm going to do here is I'm going to go ahead and draw my picture. So, and I have the cosecant of x is 13/5, so I'm going to figure out where that triangle goes so I can draw the triangle with those side lengths. So pi over 2 is equal to 90, and pi is over here at 180. So my angle is hanging out in quadrant 2. So that's what that little restriction tells me. When I go ahead and label my triangle, cosecant is the opposite of sine, not the opposite, the reciprocal. And so when I label my triangle, I'm going to have that the hypotenuse is 13, the side opposite my angle x is going to be 5, and then I can use the Pythagorean theorem to find that last side. And that's a special right triangle right here. It's a 5, 12, 13. But because of where this angle is located, you do need to make this side negative because it's in quadrant 2. Okay, so now that I have the picture, using that formula is going to be a lot easier. So if I want to find the sine of 1/2 x, or the sine of x over 2, I'm going to go ahead and look at my formula chart, and we're going to be doing that first formula. So the square root of 1 plus or minus the square root of 1 minus cosine x. Now x is that angle that we drew over here, so I can just go into my picture and I can find that the cosine of x is equal to the adjacent over the hypotenuse, and now that's the value I'm going to plug in for cosine of x. So this is going to equal to plus or minus the square root of 1/2 1 minus negative 12/13. And so if you have minus a negative, you're actually adding, and I need to find a common denominator within those parentheses. So this would be 13/13 is equivalent to 1 plus 12/13. Okay, that's my common denominator. So now at this point, I'd have plus or minus the square root of 1/2 times 25/13. Taking a little bit of work here, and then we're going to go ahead and multiply straight across, which gets me the square root of 25/26. Now when you're taking the square root of a fraction, you really are taking the square root of the top and then the square root of the bottom. And so the square root of 25 does simplify down and just be 5, and then that bottom is the square root of 26. So the last thing that we need to worry about is this piece right here, this plus or minus. And this is where it gets a little bit tricky. When you're thinking about a half angle, we're going to look at that initial domain restriction they gave us. So this pi over 2 is less than x is less than pi. If I took this and I said pi over 2 is less than x is less than pi, I have to think about now, what about x over 2? So if I divided this by 2 or multiplied by 1/2, I'd have to divide this by 2 and divide this by 2. So I would get that this is pi over 4 is less than x over 2 is less than pi over 2. I think about where does that angle put me. And so if I'm thinking about my unit circle, here's pi over 2 and here's 0. Pi over 4 is in the middle of that. So my angle is in quadrant 1. And if I remember my all students take calculus, that would tell me that any of the trig functions are going to be positive in quadrant 1. So my final answer for the sine of 1/2 x is going to be the positive version of 5 over the root 26. So again, you have to think about with that domain restriction, what does it do to my half angle as well? Where would that put my half of my angle? This one happened to still be in quadrant 1. We'll see what happens when we change that up a little bit. Okay, still got a couple pieces left on this one. We've got to find the cosine of 1/2 x. And again, that's just a formula. So I'm going to plug in to that formula on my formula chart. And that one says 1/2 times 1 plus cosine x. And so I go ahead, I already found my cosine x. So I'd have 1 plus negative 12 over 13. And adding a negative is just like subtracting. So now at this point we have 1/2. Again, this is going to be 13 over 13. But now this is minus 12 over 13. Wow, I just got super bad handwriting all of a sudden. Okay, now I have plus or minus the square root of 1/2 times 1 over 13, which would get me plus or minus the square root of 1 over 26. Okay, again, you're taking the square root of the top and the square root of the bottom, so that would just be square root of 1 is 1 over the square root of 26. We played the same game that we did before, but we already know that my half angle is going to be in quadrant 1, and in quadrant 1, cosine is positive, so we would say that the cosine of 1/2 x is equal to positive 1 over square root of 26. Okay, and then the last one they asked me to find was the tangent of 1/2 x. And if you look at that formula chart, there is some stuff that you can use for the tangent of 1/2 x. But those other formulas deal with, here I'll go look at them, these other formulas have a sine of x in them, they have a cosine of x in them, you have all this crazy stuff going on. Remember, if you ever have tangent of x, we're trying to work smarter, not harder, and I remember that the tangent of something is equal to the sine of that thing over the cosine of that same argument. And so I already found the sine of 1/2 x. I already found the cosine of 1/2 x. Let's make our life easier and plug in what we know. So we're going to have 5 over the square root of 26 divided by 1, over the square root of 26. With fractions, you keep change flip, so we would keep the first one, change my sign to multiplication, flip over the second thing. My root 26's would cancel, and I would just get that my answer would be 5 for this one. So that makes my life a lot easier than trying to go through and finding the sine of that original angle or using all that square root business and having fractions and stuff. At least now we already can use what we found. Okay. I got one last example for you just to kind of reiterate what happens when you're in different quadrants. And this one might help you with your online quiz, hint, hint. So we have if cosine x equals negative 1 over 9, with 180 is less than x is less than 270, find the cosine of x over 2. So cosine of x over 2 is the same thing as saying cosine of 1/2 x. So I can use that formula chart and find out that this is what I'm looking for. So I'd have 1/2 times the cosine, 1 plus the cosine x. Oh, my formula chart just fell down. Okay. So this is the formula I'm using. Before we had to draw the triangle because I didn't know what the value of cosine x was. Now I know it. I don't even have to draw the triangle unless you so want to. But since I already know cosine x, I can go ahead and plug it in. So I'm going to take this guy, 1 plus, now I know that that is negative 1 over 9. And now this is just a simplifying issue. So I would have that this is 9 over 9. Look at me getting all fancy in there. And so I would have that this would be equivalent to 9 minus 1 is 8 all over 9. Now I have that this is equivalent to the square root of 8 over 18, which will simplify down into 4/9. Okay, I could divide both of them by 2. So this is super nice because now what I have is the square root of 4 is 2 over the square root of 9 is 3. So this left all of my square roots gone. Now the big issue is I can't have a plus or minus answer, so I've got to take that original boundary that they gave me. I was in quadrant 3, and now I've got to divide it by 2 to find that half angle. So I'm going to be in between 90 and 135. Okay, and if I think about on my coordinate plane where that is, here's 90, and then this is 180. So in between those two angles, I'm going to be somewhere in quadrant 2. So if I am in quadrant 2, all students take calculus. Only sine is positive in quadrant 2, which tells me right now that cosine would be negative over there. So my final answer for the cosine of x over 2 would mean that I would have the negative 2/3 part of that. Okay, and that's all I've got for you today with those half angles. Remember, you still might have to prove some identities using those half angles, but you've got that formula chart, and I will see you tomorrow.